This tutorial is for the structure-based evidence module, specifically focusing on the protein data bank. So I'll open the structure-based evidence module and note that I have completed my TigerFam assignment and my PFAM assignment, one of the two PFAM assignments. And as I scroll down, I see the PDB link, and in this particular case I have already filled out these fields for this gene. So for the purpose of this tutorial, I'll go back and do another gene. In this particular gene I haven't finished the TigerFam or PFAM, but I still have the empty fields for the protein data bank. Now, the path to getting your amino acid sequence of this gene that has been assigned to you is different than the copy and paste path that we have been taking for the previous modules. In this particular path, we're going to go up here and click on the gene object identifier to the gene details page and scroll all the way to the bottom. Down here we can autofill, so we can just fill this amino acid sequence into the field box with a preset e-value cutoff that I'm going to change to 1, and search. It's going to be OK. The protein data bank. Now what is it that we just search? Another quick review. Each time we take these amino acid sequences, copy and paste them, or use them to search a database, we're taking this primary amino acid sequence and we're comparing that primary amino acid sequence with some set of algorithms against a unique or individually prepared database designed for some specific reason. In this particular case, this data bank is a repository of three-dimensional molecular structures generated by structural biologists who spend their careers crystallizing proteins and using an instrument called an X-ray diffractometer to determine the exact position of the atoms in that particular molecule. And when I say atoms, I mean carbon atoms, oxygen atoms, hydrogen atoms, and sometimes sulfur atoms. So going back to our exercise, you can see I'm looking for a code, a name, an alignment length, and an E value. It's very quick and very easy here. This is the code. Whoop. In fact, if I was really clever, which I'm not, I'll just quickly go back here and fill out my lab report at the same time, something I haven't been demonstrating to you very effective. So see, this is a not good lab report because it's not, this code is called 2onc, and then we take the name. Okay, 2onc. Don't forget 2onc. And I can also paste that name right here. And back here I can get my E value. E value is a common feature in IMG-ACT, and it represents the probability that this alignment occurred by chance. Again, it represents the probability that the alignment of your query sequence, the sequence that you have been looking at, the probability that that alignment occurred by chance. And that probability, as it approaches zero, lends evidence to the notion that whatever you're looking at, this hit that you've got, is sort of a real hit. Now in the lab notebook we're going to put, we're going to put this alignment, and you know, as I said before, it just doesn't look good unless you take and put it in Courier. Alright, so in effect, at this point, you've completed the structure-based evidence module. You've also entered this into your lab notebook or your lab report. There's one other feature that we don't require you to do, but it is by far and away one of the coolest things you can do in molecular biology and molecular genetics, and I'm going to do that right here. I'm going to click on this link and I'm going to view this particular protein in 3 dimensions. So I'm going to accept the risk, and I want to run this application. You can remember this from when I was doing Virtual Fly Lab. This will illustrate what what we're doing here. And again, the Protein Data Bank is a repository of proteins that have been crystallized and their 3-dimensional structure has been determined. This database is small because this requires an incredible effort of a lot of people. So the database of these 3D molecular structures is small. And because it's small, you oftentimes don't get a hit, and you can see, of course, our E-value, which was at the level of -7, was not as strong as some of the other BLAST E-values that we'd have been getting. But the advantage is you can really visualize how a linear primary sequence of letters, when they fold up like this, makes a 3-dimensional protein in space. And it is just something special, so I wanted to make sure everybody has the opportunity to try that out, even though we don't have any requirement in this particular module for you to do this. So thanks for watching.